Is it? I'm audible. I'm audible and
Yes, sir.
yes. Okay. Okay, in the last lecture, we have discussed about the Taylor series and the Maclaurin series. So, first problems we have discussed is how from the Taylor series we getting the means Maclaurin series. Okay, so Lagrange's form of remainder in the expanse terms when n tends to infinity. When the error terms means remainder after the n terms becomes zero, then we get the Taylor series. Okay. And when we take about the point when a is equal to 0, so it's now become the Maclaurin series. These things we have written here in this last lectures. Okay, and what we get the x minus 0 power something that is called the power of both the Taylor series and Maclaurin series. Taylor series about any point, Maclaurin series is fixed about the origin or 0. Okay, so one question I have expanded the 10 inverse x in powers of x minus 1. So so here is not this is about the point 1. Okay, so interval is 1 to x I have already written, not 0 to x. So when we write 0 to x, that means that become the Maclaurin series. Okay, no issue. Maclaurin series is the special case of the Taylor series. So in this case, you have to differentiate all the terms and um, you put all these values you will have. So not solve that one last lecture. Those who have solved, okay, but I need to solve this one. Hmm. Still joining some people, so it's creating disturbance. And so, okay. So here is what given. And solution started from here. Solution is what here. So in this case, fx is equal to 10 inverse x. Okay, therefore f of 0 is equal to, so 10 0 is what we write. So this is pi by 4 as we know the values of yes. Next is abscess of x is
So
equal
f of 1 5 pi by 4 होगा.
f of 1. Yes, not 0 also. Hmm. F of 1 is equal to pi by 4. Evidence of x tan inverse differentiation we will have 1 upon x square. Therefore, f of 1, f dash of 1 is equal to, you take the 1, so 1 upon 2. Similarly, f double dash of x is equal to, so it's power 1 and okay, so 2 upon 1 plus x whole square and now the 2x.
So x होगा x.
Yeah, yeah. Therefore, f double dash of 1 is equal to minus half, and we are taking the values. Okay, so similarly, f triple dash x you can calculate. Okay, so I have this means it's lower UV form. Okay, u upon v. So 1 plus x square whole square, and that is the term is minus 2 minus 2x into 2 into 1 plus x square into 2x 1 plus x square power 4. Okay, so after simplifications, what the things you will get here, but when you take the values here, therefore f triple dash of 1 is equal to, you put the values, we will have again 1 by 2 something. Okay, so you can do if possible, don't make it too much lengthy, just 3 4 tak you can go. Now knowing this is the Taylor series, so you put all the values using above terms in the equation. So equation number you can say 1, we have 10 verse x pi by 4 plus 1 by 2 x minus 1, this is the power minus 4 x minus 1 whole square 1 upon 12 x minus cube plus dot. So this is your answer. Okay. Similarly, we can add more the problems for Taylor series, like expand the polynomials 2x cube plus 7x square x minus 1 in powers of x minus 2. Okay, powers of x minus 2. So solution, you can first you find all the derivatives. Okay, and the given is what, x minus 2. So that means about the point. So you hmm, mm, by Taylor says for fx about the point x is equal to 2. What we write here. So this is fx is equal to 2x cube plus 7x squared plus x minus 1 is equal to so we have this is the interval is what it is x is equal to 2, that means interval is here 2 and x. So f of 2 plus uh, power power is x minus 2 factorial 1 f of dash 2 x minus 2 whole square factorial 2 double dash of 2. Okay, and this is the polynomial means after third degrees it will be vanishes automatically. Okay, because contains the third degree. So we can write all the terms. Square answer cube, 3 factorial, triple dash is 2. Okay, so by the Taylor series you write this one. Things. After that, you find this since fx is equal to 2x cube plus 7 square x minus 1. So therefore, f of 2 is equal to, if you take the values, so you will have after calculation 45. F base of x is equal to 6x square plus 14x plus 1. Therefore, f of 2 is equal to, the value is after calculation, okay, is 53, which is dash here, double dash of x, 6, 12x plus 14 only. Therefore, double dash of 2 is equal to 38. Okay, double dash this completed. We can we must find about is equal to differentiating. We will have only one constant terms 12, and after that it becomes 0 when it says the f triple dash 2 is equal to 12. So using all terms in equation 1, we have, so what we write, fx is equal to 45 x minus 2 and 53 plus next is 38. Okay, factorial 1. Here is x minus 2 square by 2. Okay, we can cancel it. The next is 12 square factorial 3, that means 6. So we are getting 45, 53, x minus 2, and 9, 10 x minus 2, and plus 2 x minus 2 whole square. Sorry, cube, not square. This one, cube. Hmm. This is the cube.
So the 19 minus x minus 2 square.
But this is divided by 38 divided by 2. It's 19x minus 2.
एक्स माइनस टू का स्क्वायर बोल रहा
Square होगा.
Yes, sir. Yes, yes. Okay, so this is your answer. Uh, 2x cube plus 7x square uh, 1 times x minus 1. Okay, so this is your answer. So if there is a question, okay, approximate for the value. Okay, this is the expansion of this one using the Taylor's expansion. Similarly, you can just find the expansion of 10x of power x minus pi by 4. Here is the means this is the power series actually. Okay, means alternately we can also say Taylor series. This is okay, and also say the power series. Power series, that means power of what, x minus something 2. We according to that. So this means what, power series is shifting of the origin, that. Okay, Maclaurin's is about the origin, and we are shifting the origin x minus 2, and we are finding the in powers of that. In similar manner, you can expand 10x in powers of x minus pi by 4 up to first 4 terms. Okay, you can do this one yourself. Hmm. Next question. Okay, you can also try this one. Prove that first. Log of 1 plus x square x cube x to the power 4 is equal to x plus square by 2 plus x cube upon 3 power 4 upon 4 minus 4 upon 5 x to the power 5 power 6 upon 6 plus dot dot. Ah, yes. Yes, anybody? 2 1 plus x to the power x is equal to 1 plus x square x cube by 2 5 upon 6 by x to the power 4 minus 3 by 4 x to the power 5 40 x to the power 6 plus dot dot. Okay, so in this case you see, prove that it is correct to 4 decimal places using Taylor's theorem. Okay, in this case, Taylor's series we use theorem. That means series also included. In that case, better to write series. otherwise make it confusing. Series. So what we do in this case? How we have to approximate the values of this one. Okay. Uh, so what we are going to do, we we assume the function, and so that the final
Root
value, root x we have to assume, and there is the we take the values of x such that it's make a expansion. Means expansion, how we write? Yes, message. Yes, Rajesh Eagle. Any question? Let fx is equal to root x. So when then you write the Indian expenses. Okay. So what you do in this case, by the Taylor series, we have to expand, and this expansion is what? About the origin or about the, because we have to take the values of x something.
Sir, about 10 we should take,
About
na?
10. Hmm. About 10. 10 is means we take the value at the last point. Um, okay. No, so we are considering the interval. Taylor series affects for interval is uh, we should write x comma x plus h if we are taking. So then what happened? Interval we are taking x and x plus h, means to say x is equal to 9 and h is equal to 1. Then what happened? Then it is about the root 10 x, and it's become about the point 9. So Taylor series of fx for x plus h. So in this case, we write the Taylor series about the point x. That means f of x plus h is equal to f of x plus, we write here. So x plus h minus x is what? H upon factorial 1 f dash of x. Next is h square factorial 2, same thing, f double dash of x. So four decimal places means what we take the approximation, it should be four decimal places, means three. If we get some values of root 10 is something 3 point something, four decimal places. Okay. If no problem, if you are getting five decimal places, just round up there and write the approximate. Okay, let me do. We can do up to 3, 4. Okay, but we do here up to 3 um, plus x q upon factorial 3 f triple dash of x plus triple dash. Okay. So we are taking up to here 3 decimal place, 4 decimal places enough to find. Next, what you do, so fx is, we know that root x, okay, that's the other things, x. So um, what we take, x is equal to 9 and h is equal to 1. Okay. Mm, So this implies that root of x plus h, f of x plus h upon factorial 1, the same thing I'm writing, plus h cube upon factorial 3 triple dash of x. Okay, in the infinite series actually it's become, we can terminate up to 3 by. Now fx is equal to root x. Hmm. So f dash of x is equal to 1 by 2 differentiation. What we get? Minus half, fine. Okay. Double dash of x is equal to minus 4 x to the power 3 by 2. And this triple dash of x is equal to, so minus 3 by 2. How much we get multiplying all the things?
So 3/8.
3 by 8. This is plus x to the power minus 5 by 2. Okay, we can proceed ahead, but we stop here the things. So yeah, we are using this term. We have, so we have root of x plus h. So this is root x plus, okay, we are not taking now value, f dash of x minus half square into double dash minus 1 by 4 3 by 2 plus h cube factorial 3 and minus, sorry, plus 3 by 8 x to the power minus 5 by 2. This is we have. We need to evaluate. Now you take the value. X is equal to 9 and h is equal to 1. Okay. Therefore, so 9 plus 1 is equal to root 9 plus 1 by factorial 1, and this is the, we are taking x is equal to 9. Okay. Plus 1 factorial 2. This is minus 4 and 3 by 2 plus factorial 3, 3 by 8 power minus 5 by 2. Okay. Hmm. So this is root 10 is equal to this 3. Now it's 1 upon, this is 3 square minus 1 upon 3 plus minus 8 and 3 it's become 3 square. 3 square, this is 3 plus factorial 3 is cancelled, 2 into 1 upon 8 and 9 power minus 5, that means 1 upon 3 to the power 5. Okay, so after this putting all the values means you simplify, so we will have such type of value 3.16227. Okay, approx. That should be 3 plus 1 by 6. Okay.
Sir, in second term, 1 by 2 we are missing.
Okay, okay, that that's it. Yes, 1 upon 6. Okay. So other things I say maybe. So this is your answer. In this manner, you have to evaluate the such values. Means we are doing for the small one. Suppose on the big one problem, on that case we can do. So in this case, we are not taking the directly x is equal to 10. Okay, to evaluate because we need to write about the any point. So we choose there x comma x plus h. We are writing about the x so that given function is root x. We assume and we are taking the value and finally root 10 we are getting. Now we see for the a Maclaurin series problem. Okay, so Maclaurin series, that means obvious about the point zero, about the origin. Question. Assuming the validity of exponential, so that log of 1 plus sine x, x minus square by 2 plus 2 upon 6 power 4 upon 12 plus dot dot solution. Okay, see, this expansion is written is not in the power of x minus a something. It's just written x square. That means x minus 0. So we need to go through, or we can Taylor series and Maclaurin's is nothing too much difference. And Maclaurin's already I said is the special case about the origin. Okay, so you can write here. Let fx is equal to log of 1 plus sine x. Fine. So thus by Maclaurin series for fx is given by fx is equal to f of 0 plus x f dash of 0. This is 1 factorial square factorial 2 f double dash of 0. So this is the up to 4 degree. Okay, so cube 3 factorial triple dash 0 power 4 everything so 4 0 and plus. Okay, so this is 4 degree terms. And so now fx is equal to log of 1 plus sin x. So therefore f of 0 is how much? Anybody?
Sir, 1.
1.
1, sir.
Zero.
1.
Sir, zero.
Zero. Zero.
Sir, 0. 0.
0, correct. Means when is equal to sine 0 is 0 and log 1 is 0. Okay, so f of 0 is equal to 0. Next, similarly, f dash of x, what we write? Hmm? Okay, anybody? Okay, I can
Cos
write.
x by 1 plus sin x.
1 plus sin x.
Cos x upon 1 plus sin x.
Okay, cos x upon 1 plus sin x. Fine. Therefore, f dash of 0 is equal to
1.
1.
One.
double dash of x
Minus 1.
minus what? Yes, calculate.
Minus 1, sir.
Okay,
Net value minus 1.
okay, value is minus 1. So minus 1. But what is the f double dash x? Minus,
Minus 1 upon 1 plus sin x.
correct. So Pradeep Agarwal, you said saying sin x triple dash of x cos x upon 1 plus sin x whole square. So therefore, double triple dash of 0 is equal to 1. You see here the terms are 0, 1 minus 1 like it's getting. Okay, similarly, for fourth one, we will have some values. Okay, you write here, therefore, but this value is minus 2. Now we are putting these all the values in the Maclaurin series. After Maclaurin series, so can we get the same term? Are we getting the same this one? Log of 1 plus sin x is equal to x minus square upon 2 plus x cube upon 6 minus power 4 upon 12. Are you getting when you are using all this value in the Maclaurin series?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so while class you can use your one copy, one pen so that you do something with me. Hmm. So this is the question of so that the other question, find the Maclaurin series expansion of log of 1 plus e to the power x. Okay, so I think you can do this one. So you can do this one, and similarly, we can write the exponential series, logarithmic series using the remainder term. So what happened in the series of exponential logarithmic? So in that remainder terms after the end term, that is tends to zero, is tends to infinity. Okay. So one thing, today's this series are finished, Maclaurin and all the things. In the next lecture, we are going to start the tracing of curves. Okay, so in which you understand how to trace a curve. Okay, not for only like one simple curve, x square, parabola, hyperbola. It is not like that. It is called like cardioid and some leaf type curve, and these are the things in the both cases, Cartesian and one more polar coordinates. Okay, so today we are finishing this all series. Okay, you do more practice the questions uh, using engineering mathematics book. And one thing I'm telling about the last one. So these all exponential logarithmic series is extracted from using the Taylor series. Okay, so first we write the Taylor series with the Lagrange's form of remainder. Okay, there is the remainder tends to zero as n tends to infinity. Okay, the last one we quickly completed. Exponential series. Exponential series is what? E to the power x, we know that 1 plus x upon factorial 1 from factorial to x square. Okay, x cube. Like, uh, so using the Taylor's by Taylor's extension with Lagrange's form of remainder. So we already know these things. Fx is equal to, okay. So what we write means we writing the about the origin. So f of 0. Okay. Now x minus 0. Factorial 1, x minus 0. This is x is here. F dash of 0. Square factorial 2. Means this is the interval is here 0 and x. We are writing the expansion of e to the power x. Double dash of 0. Okay, it's like that, and it is written up to nth n term power n factorial, nth derivatives, and plus rn means remainder after the n terms, or remainder of order n. So this is the x to the power n plus 1 upon n plus 1 factorials and f of n plus 1 derivatives. You can write theta x or theta, whatever the things you can write, no issue. So theta is less than x and greater than 0. The things are here important. Here, remainder if we write remainder after n terms or remainder of order n as Rn is equal to h to the power n plus 1, 1 factorial f of n plus 1 theta. Okay, so this, when would nth derivatives of exponential e to the power, what we get, same thing, and we take e to the power theta. So when we take the modulus, so that means x to the power n plus 1 and n plus 1 factorial. So e to the power theta, this one. Now we are taking the limit as n tends to infinity of Ra. And these things we can write e to the power theta modulus. But theta is bounded for a given x. Okay. So it is that for all x, since e to the power theta is bounded for given x. Hence, we obtain the exponential series. Okay, so that means n tends to infinity is equal to 0. So this term is bounded because factorial n plus 1. So x is bounded. So e to the power x 1 plus factorial 1 factorial 2x upon factorial. So like that is going on. So similarly, we can write for the log x. It is for just for information. Okay, if it is useful, some places you can do. Now this series, your Taylor's and Maclaurin series completed, and like the problems you practice in similar way. Okay, any doubts? Anybody?
No, sir.
Okay, so I'm sharing this notes. Today's notes. Actually, I'm writing in the one page. So it is all up to today will be served. Okay, so those who have not done attendance,
Okay,
mark
sir.
attendance. I think you have another class. Okay. So now I'm leaving, and on the Sunday I will take the class advance for Monday class. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Thank you. Thank you.